Good morning. I'm Suzanne Higgins. I'm a soil scientist at AFBI. Today I'm going to be talking about farm and field management of phosphorus inputs, and I'm working on the nutrient management component of catchment care. Agricultural land acts as a point and diffuse source of phosphorus loss into waterways. Recent soil sampling schemes, such as the EAA scheme, have showed that 50% of soils in Northern Ireland contain high or surplus levels of soil P. By this we mean soil P which is above what is required for agronomic production. And when there's high soil P levels, there's increased risk of P loss into waterways. So the map here is from the recent EAA soil sampling scheme across Northern Ireland. The orange and the red colours indicate fields or areas of land which are index 3 or above in phosphorus, which means high or excessive soil phosphorus content. So phosphorus loss can occur during storm events. It can also occur over the winter whenever the soils are saturated for quite a long period of time. Soil phosphorus can also be lost due to riverbank erosion, and this is particularly prevalent in flashy catchments where you can have a lot of soil and sediment loss. So I'm going to show a video now of a storm event which occurred in November 2020. So these storm events maybe occur once or twice a year, but they're becoming more frequent. And this is when it rains just continuously, quite high intensity for 1 or 2 days. And the soil just becomes saturated and the water runs over the surface. And this, the river channel here, this is usually just a normal, very small stream, but due to the volume of water, it's actually developed into quite uh, um, quite a raging river channel there, and in this kind of event there'd be a lot of soil loss and phosphorus loss. You can also get phosphorus loss by animals poaching, especially in riverbanks, and animals getting access into rivers. You can also get phosphorus loss from farmyards. So the aim of catchment care is to identify strategies to help manage phosphorus inputs at farm level and individual field level. So what we want to do is reduce the number of fields which are oversupplied with P. We want to develop an evidence base that will help shape future regulations in relation to soil nutrient management. And we also want to develop recommendations that are appropriate for cross-border farms. So current fertilizer recommendations favour high production systems. So this is grassland receiving high inputs of nitrogen. So fertilizer manure up to 360 kilograms of nitrogen per hectare per year. So these systems would have high target yields of 12 to 16 tonnes of dry matter per hectare per year, and they usually have around 3 cuts of silage. However, much of Northern Ireland and the Republic of Ireland is not operating at this intensity. Extensively managed livestock farms in Northern Ireland would generally only have total fertiliser inputs of less than 60 kilograms of nitrogen per hectare per year, and manure less than 120 kilograms of nitrogen per hectare per year. The expected yields of these systems would be 4 to 7 tonnes of dry matter per hectare per year. They may take 1 or 2 silage cuts, and many of these farmers would be part-time farmers. So extensively managed grasslands is a landscape which comprises a large proportion of the land area of Northern Ireland and the Republic of Ireland. But currently we have minimal published data assessing the phosphorus requirements of these low input extensive systems. So in terms of grass growth, the maximum grass yield is determined by the most limiting nutrient. So in an extensive system, the low nitrogen rate is generally the limiting factor. So when you have a low nitrogen input, such as 60 kilograms of nitrogen per hectare per year, the maximum attainable yield may be around 7 tonnes of dry matter per hectare per year. So even if you apply more P to this system, the yield won't increase because it is limited by the nitrogen input. So where the nitrogen input is low, such as an extensive grassland system, the P uptake by the grass would be lower and the P requirement would be lower. So on an input of 60 kilograms of nitrogen per hectare per year, the soil P level can be lower. So Olsen P index of such as index 1 may be sufficient. The level of P in the soil may be sufficient to support an extensive grassland system. Whereas if you are in a higher nitrogen input system, where you've higher yields, higher nitrogen input, higher rates of growth, you would need more phosphorus, and so your soil phosphorus level can be higher, so up to an index of 2+. So you can see on the graph here, the lower line is for an extensive system and the upper line is for a more intensive system where there's higher yields, greater number of cuts. But you can see that the graph flattens out. This means that there's no more yield response. So when your soil index is greater than index 2, you don't have any more grass response to phosphorus. So there's no need to have your soil phosphorus higher than index 2. So what we want to do in catchment care is tackle the high levels of legacy soil P. So this is where more P has been applied than is required for production. So catchment care aims to refine the nutrient advice given to farmers. It focuses on farm specific advice and farm activity level. So we're working with 17 farmers in the Blackwater cross-border catchment. So this is Armagh, Monaghan and Tyrone. So we sampled 400 fields in the Blackwater catchment. We found that 66% of fields contained excessive soil phosphorus. So this is soil phosphorus index 3 or above in Olsen P. And so this is fields to the right-hand side of the red line on the graph. And this is soil which the phosphorus level is above what is required for agronomic production. And this 66% is higher than the national average. So this catchment is particularly high in soil phosphorus. So there have been revisions to the Nitrates Action Programme and the phosphorus regulations in Northern Ireland. This is in the recent edition 2019 to 2022. Okay, so in the UK, soil is classified as soil phosphorus is measured by the Olsen soil P test, and the phosphorus is divided into an index system, index 0 to index 4. So an index 4 would mean the soil is deficient in phosphorus, a 1 would be low, 2 would be optimum, 3 would be high, and 4 would be excessive. So in the new Nitrates Action Programme, what we have recommended is that index 2 be split into a 2- and a 2+. So the lower end of index 2 would be more suitable for extensive grassland farms where the P requirement is lower, and a 2+ would be more suitable for a more intensively managed farm. In the Republic of Ireland, soil P is measured by the Morgan's test. And it is also divided into an index system, index 1 to index 4. So index 1 would be very low, index 2 would be low, index 3 would be optimum, and index 4 would be high. So the two tests are very different. So the actual value of phosphorus measured would give a very different figure, but the index system is based on a similar kind of principle of low to high. So what we're trying to do in catchment care is to look at this issue of two soil tests operating in quite close proximity in a cross-border area, such as Monaghan, and see whether the recommendations for phosphorus will vary significantly and then impact on the advice we are giving to farmers in cross-border areas. So we've analysed hundreds of soil samples from the Blackwater catchment and also from the ACP programme. And there's quite a good relationship between the Olsen and the Morgan P. But whenever you then categorise it as an index, there are some discrepancies in whether a soil, for example, may be classed as an index 3 based on the Olsen test, which means no more phosphorus should be applied, whereas on the Morgan's system, it may be an index 2 where they would recommend phosphorus. So we're trying to see what impact this might have on water quality and what impact this may have for farmers in border areas where, depending on what soil test they use, what advice they are given and whether they apply soil P and how this impacts on water quality potentially. So in the new nitrates action programme in Northern Ireland, there are new fertiliser recommendations for an extensive system based on a soil P index of 2-. And what we're doing is testing these recommendations in a field trial. So we're now in our final year of this 3-year trial. We're looking at 3 farms and different rates of phosphorus applied. Then we're looking at the impact on grass yield and grass quality. So this is the first farm here. So the 3 farms are quite low in phosphorus. So this is an index 1 in terms of Olsen soil P. So it has a soil P requirement. And you can see this is this is a typical extensively managed system. So this field will be quite wet. It generally be used for grazing. You can see rushes in the field. This field here is in Clogher. It's also a grazed field. So we're applying different rates of P and looking at the rate based on the new recommendations. And you can see the yields we're getting are good yields based on 2 cuts. So you get 7 tons a hectare dry matter from 2 cuts. You can even see the plots which got no phosphorus at all are still getting over 6 tons of dry matter per hectare per year. So there's a lot of mineralization of soil phosphorus happening even when no phosphorus is applied. And there's still quite good yields even when no more phosphorus is applied. And then the final site we have is a silage site. So this field will get cut twice a year for silage. It has slightly higher nitrogen inputs because it is a silage system. And we're seeing then, looking at the silage recommendation for an extensive system, and we have still got good yields based on the new recommendations. So the revised P recommendations for extensive grassland are appropriate. We had no P deficiency in the grass in plots receiving any of the P rates, but there were some signs of P deficiency in control plots where no P was applied, particularly in the silage site where there's a higher nitrogen input. So it's very important if your soil is index 0, 1 or 2-, that there is a P requirement. So you do need some P, particularly to protect animal health. But the key thing is not to apply any more than is required for agronomic production. So I'm just moving on now to the knowledge transfer component of Catchment CARE. So we have produced nutrient management plans for the 17 farms in the Blackwater catchment that we're working on. We have then classified each of their fields based on a traffic light system. So the red fields here would mean those fields are high in phosphorus and no more phosphorus should be applied. So those fields are index 3 or above. Then the green fields would be optimum for phosphorus. So they would receive phosphorus based on the index 2- recommendation. And then the yellow fields are index 1. So they'd be low in phosphorus and require phosphorus requirements based on the index 1 recommendation. We've also calculating farm P balances and we're making recommendations for improved fertiliser and slurry management on these farms. So based on these maps, we have found a 42% reduction in the amount of P applied through inorganic fertiliser on these farms. So these kind of nutrient management maps, which are colour coded, have been shown to be a very effective way of communicating with farmers. They understand and very often they're very grateful for the advice given where they need to apply phosphorus and where they don't. We're also taking grass samples. So this is a reassurance to farmers to show them that their grass has enough phosphorus in it and it isn't deficient in phosphorus, even if we've told them not to apply any more phosphorus. So these grass samples are just a reassurance measure for the farmers so that they're happy with the advice that they're receiving. Another component of the project is we're looking at the subfield variability in phosphorus. So this is work by a PhD student, Emma Hayes, and she has sampled these fields based on a grid. So normally you only have one phosphorus value for an entire field area, but you can see by sampling on a grid, you can pick out hotspots of phosphorus where there's particularly excessive levels of phosphorus in certain parts of the field, but not across the whole field. Then Emma, if you see the map on the left-hand side, Emma has used drones and LiDAR to map potential runoff channels. This is where potentially these could be channels where phosphorus could be lost into waterways. So there's a river running alongside this field. And then you can see the field on the right-hand side. And within this field, there are areas of deficiency in phosphorus right up to areas which are excessive in phosphorus, all in the one field. So the advice we would give here would be that the farmer should apply phosphorus or fertilizer or slurry to the left-hand side of the field where there's a phosphorus requirement. But on the right-hand side, where there's already high or excessive levels of phosphorus, no more phosphorus should be applied to these parts of the field. So Emma's study is showing there's huge subfield variability in phosphorus, and we need to refine the recommendations to a subfield scale, particularly in areas where there's greatest risk of P loss into waterways. So the conclusions then, based on the first 2 years of data, the revised P fertilizer recommendations in the 2019 to 2022 Nitrates Action Programme are appropriate for extensive grassland systems. So extensive farms can obtain sufficient grass at a lower soil P index. And if we refine the nutrient management based on farm intensity, we can help reduce P surpluses. So the Catchment CARE project would just like to sincerely thank the 17 farmers in the Blackwater catchment who are involved in this study, who've let us use their land and have been very good at providing farm management information for the project. Okay, thank you.